So here we are at the 0.2 set of notes, kind of going over the definition of a rational function in example 1. The definition of a rational function is simply just a function where we have some polynomial on top and some polynomial on the bottom. And as long as that bottom is not equal to 0, things work out okay. Now when we're talking about the domain of a rational function, this is pretty much whatever x can be for this particular rational function. Now, and again, that's only where things are actually defined. And it kind of ties really well with this part where this bottom piece is not equal to 0. That's where we pretty much see where the domain is everything except for where that bottom is not equal to 0. Now, when we go to example 1, it's asking, well, what is the domain of this particular function? F of x, which is equal to 1 over this 2x minus 5. Well, again, since we said that functions, these rational functions, can be pretty much any x value except where the bottom is not equal to 0, because again, that's where we start seeing that undefined statement. And as a result, all we're going to do is simply set 2x minus 5 is not equal to 0, and actually then find for what x values is that actually happening at, where we see that undefined statement. Because the alternative, if it is undefined, well, everything else then would be defined. So that's why we're actually trying to find out, well, where is it not equal to 0? So when we solve for this, if we just add 5 to both sides, we end up with 2x is not equal to 5. And then just divide 2 on both sides, we end up with x is by himself is not equal to 5 halves. So in other words, for the domain, we have all real numbers except where x is not equal to 5 halves. Now when we look at this other function, this g of x function, which is 1 over the x squared plus 3x plus 2, we're kind of in that same situation where we just set that bottom not equal to 0 and then try and solve it from there. So we have x squared plus 3x plus 2 is not equal to 0. Well, in just looking at this, we notice that it is in fact a quadratic, and we can go ahead then and factor that guy. There are other methods that we can use, but it seems like factoring is going to be the quickest and easiest one to actually do. So when we factor, we end up with x plus 2 times x plus 1 is not equal to 0. Using that zero product property, it says that we can pretty much break these up and have each of them not equal to 0. So we have x plus 2 is not equal to 0. And this x plus 1 is not equal to 0. And now you just solve for each one. So we end up then with x is not equal to negative 2. And x is not equal to negative 1. So as a result, for the g of x function, we have our domain can be any real number except where x is not equal to negative 2 and negative 1. So x, in other words, can be anything else except for negative 2 or negative 1. That's what this statement is saying. So again, that is the definition for the rational function, domain, and example 1.